Hey, welcome to Trixa. Today we'll be talking about Riemann sums. So let's get started. Over here I have the equation written for finding a Riemann sum, but let me break it down for you. So first we have A. A is the area. Riemann sum is a good introduction to integral calculus, and you'll soon find out integral calculus is all about finding the area beneath the curve of a function. So it makes sense that we'll start by finding a formula for area. And the next thing you'll see is that we have the sigma notation. So what does the sigma notation mean? Well, it means sum of the terms that precede. And we see I equals 1. So I is the number we start at. So we're starting at the number 1 and we're going to the number n. And so n is the number of rectangles. And the way that you find the area under the curve is by splitting the area under the curve into separate rectangles. And so the sigma is saying that you're adding all the areas of the rectangles, and n is the amount of rectangles that you're breaking the area into. So let's see. So you're adding all of these terms of each rectangle. So delta x, we know, means the change in x. So that's the base, or the width of the rectangle. And then f of x of I is equal to the height of the rectangle. So we're adding all of the base times the height of the rectangle of an n amount of rectangles to find the area underneath a curve. Let's see how this works. So over here I have a curve. And underneath the curve, I'm going to draw a lot of rectangles. Let's say over here, 3, 4, 5, 6, 7, 8. Let's say I want to approximate the area under this curve by drawing n equals 8 rectangles. So over here, I would have one. I would have one over here, and I'll keep on drawing all the rectangles until I have 8 rectangles total. So the width of each rectangle is delta x. That's the x value of each rectangle. And the height of each rectangle is f of x of I. So now you'll notice the area of each rectangle is delta x times f of x of I. And now this formula makes sense. You have to add the area of all these rectangles to get a good estimation of the area underneath the curve. It's also important to note that Riemann sums are approximations. And they can be more or less accurate depending on which technique you use. For example, the greater the amount of rectangles you choose, the more accurate the area will be estimated. Which is why you'll see when we're finding integrals, which we'll be getting on in later videos, that's when you set the limit of n to infinity. You have an infinite amount of rectangles, and the sum becomes so precise, it becomes almost an exact answer. Thank you for watching this video. I hope you enjoyed. If you have any questions or any other calculus concepts you'd like me to discuss, please just leave a comment down below and I'll try to make the video as soon as possible. As always, thank you for watching. I'll see you later.